February 18, 2021. NASA's Perseverance rover pierces through the thin Martian atmosphere. Descending at 13,000 miles per hour, the world watches as the most advanced rover ever built touches down on the Jezero crater, a place that might hold evidence of ancient life. As its onboard cameras capture the first high-resolution images of an alien world, a surprising technology runs behind the scenes. Not C++, not Java, Python. Yes, Python, a language originally built in 1989 as a holiday side project by Dutch programmer Guido van Rossum, is now powering space exploration. It helps NASA process images, analyze terrain, and even control robotic instruments millions of miles away. But Python's path to global dominance wasn't as smooth as its syntax. It was once dismissed as too slow. It fought a brutal community split that nearly tore it apart. For years, developers scoffed at its enforced indentation, its so-called weak performance, and the notion that a scripting language could ever compete with Java or C++. And yet, today, Python is everywhere, from AI research labs to Wall Street, from Hollywood visual effects to cybersecurity, from Google's backend to NASA's mission control. So how did a simple scripting language evolve into one of the most powerful forces in modern computing? This is Python's Untold Story, a saga of innovation, controversy, and survival. Our story begins in the late 1980s in the Netherlands. Dutch programmer Guido van Rossum, working at a research institute, CWI, decided to build his own scripting language as a holiday hobby project. He had worked with a teaching language called ABC and wanted a more practical, extensible successor for everyday programming. By December 1989, Guido had started coding what would become Python and released the first version in early 1991. Why Python? Van Rossum, a fan of the irreverent British comedy Monty Python's Flying Circus, picked the name not after the snake, but the comedy group. The whimsical name disguised the seriousness of the vision behind the language. From the outset, Python's design set it apart. Guido wasn't trying to build the fastest language, but the most approachable. He envisioned an easy and intuitive language just as powerful as major competitors, with code that reads like plain English. Python's design emphasized readability from the start, indentation over braces, clean syntax, and a consistent minimalist approach. The guiding mantra: there should be one, and preferably only one, obvious way to do it. It prioritized readability and clarity, helping users write and understand code with minimal friction. This vision materialized in a language open to everyone, scriptable yet powerful, with a robust standard library out of the box. In February 1991, Guido shared his creation on Usenet and Python was born, but it still needed a user base in a world filled with other programming languages. Before we explore how Python found its first true believers, here's a quick word from floppy data, especially relevant if your work involves scraping, automation, or managing multiple online accounts. If you're dealing with blocked websites, managing multiple accounts, or facing IP bans, you know how quickly these problems can pile up. Proxies solve these issues better than VPNs, especially when you need speed, flexibility, and reliability. That's where floppy data comes in. Floppy data is a powerful proxy service designed to make online activity secure, seamless, and accessible from anywhere in the world. Whether you need proxies for secure browsing, automation, or large-scale data collection, floppy data has you covered. Floppy data lets you access millions of IPs across 195 plus locations, offering residential, mobile, and data center proxies. Whether you're scraping, automating tasks, or managing accounts, floppy data keeps you anonymous and efficient. With team tools and pricing from just 90 cents per GB, visit floppydata.com by clicking a link in the description to claim your special offer. I highly recommend Floppy Data, a fast, affordable, and reliable proxy solution for developers and automation pros alike. Now, back to the story of Python, because while it started small, the 1990s would prove pivotal in shaping its rise. In the 1990s, Python was an outsider. Distributed via FTP and mailing lists, it had to compete with Perl and a rising star Java. Perl, created in 1987, dominated the scripting world with its flexibility and early web usage. Java, launched in 1995, offered enterprise strength and wide platform compatibility. Python's readability quietly attracted academics, hackers, and programmers disillusioned by Perl's complexity and lack of consistency. Where Perl embraced multiple ways to solve a problem, Python favored consistency. As one early user said, "Good Python code has a very obvious structure." This readability began converting believers. A light-hearted rivalry grew between Python and Perl communities, both powerful but philosophically opposed. While Perl was the web's duct tape, Python became the clean, elegant alternative. The real breakout came with the internet's second wave in the late 1990s and early 2000s. Web apps were booming and Python was ready. Then came Google. In the 2000s, the search giant adopted Python for internal tools and back-end systems. Their motto: Python where we can, C++ where we must. They even hired Guido van Rossum in 2005. Google's endorsement gave Python a credibility boost no grassroots community alone could achieve. Meanwhile, Python 2 was released in 2000, introducing garbage collection and Unicode support. Web frameworks like Django and Flask emerged, offering both comprehensive and minimalist approaches to web development. While the Python package index grew rapidly, Python's ecosystem flourished. Yet even as it grew, new threats emerged. But another wave was coming, this time powered by data. The 2010s marked Python's explosive rise in data science and machine learning. Libraries like NumPy, Pandas, and scikit-learn made Python the language of choice for analysts and researchers. When TensorFlow and PyTorch arrived, Python became the front end for modern AI development. Even long-time R users began migrating, drawn by Python's growing ecosystem and ease of use. Python wasn't just powering websites anymore, it was driving global insights, training neural networks, and unlocking the potential of big data. Tools like Anaconda made scientific Python easy to use, while Jupyter Notebooks revolutionized how researchers shared and visualized their work, blending narrative, code, and results in one place. Yet, while Python was gaining ground in science and research, the world of web development was rapidly shifting. Ruby on Rails captivated startups. JavaScript conquered the browser. Mobile development exploded, an area where Python lacked native strength. For a time, it seemed Python might remain an academic tool, rather than a force in modern software. Over 3 decades, Python's evolution followed a steady arc of innovation. It began in 1991 with version 0.9, introducing clean syntax and scriptable power. In 2000, Python 2 added Unicode support and garbage collection, fueling community growth. Then came the pivotal Python 3 in 2008, a bold but controversial rewrite that resolved long-standing issues. In the 2010s and beyond, Python embraced async programming, type hints, and performance improvements, ensuring its relevance in a rapidly evolving tech landscape. Python 3 marked a turning point. Its backward incompatible changes forced a decade-long migration, but ultimately modernized the language and ensured its future. Python 2 was finally retired in 2020. Technical challenges remained. The Global Interpreter Lock, GIL, limited multi-threading, leading to debates. Alternatives like PyPy and proposals to remove the GIL aimed to address performance concerns. Governance also shifted. In 2018, after fierce and draining debates over proposed syntax changes like the walrus operator, Guido stepped down from his leadership role. The decision shocked the community. After nearly 30 years at the helm, Python's creator had walked away, weary from the burden of balancing vision and consensus. Yet, the language kept moving forward, fueled by its community. And that community wasn't just a loose network of users, it was organized, passionate, and global. The Python Software Foundation helped guide its growth. Events like PyCon, held around the world, turned Python into a social movement. Developers came not just to code, but to mentor, teach, and build a better future, together. Now in its 4th decade, Python faces both competition and opportunity. Version 3.11 brought major speed improvements, and future versions may remove the GIL entirely. New challenges are targeting Python's weak spots. Julia, for instance, shines in scientific computing but struggles with ecosystem depth. Rust offers C++ level performance and is increasingly used to speed up Python internals. Meanwhile, Mojo combines Python's simplicity with C++ speed, positioning itself to transform AI development workflows. Still, Python's massive community, robust libraries, and flexibility make it tough to replace. From scripting in Blender and controlling Maya in animation studios, to automating Excel and serving as a control layer in Rust-powered engines, Python's flexibility continues to grow. Guido's vision, computer programming for everybody, took shape through Python's unexpected influence in education, startups, and global open-source collaboration. Python made code accessible. Matplotlib and Seaborn brought data to life with powerful visualization tools. Pip and virtualenv gave developers control over dependencies and environments, critical for modern workflows. The Hour of Code initiative brought Python to classrooms worldwide, helping millions take their first steps into programming. In Hollywood, Python orchestrated lighting rigs and special effects in blockbusters like The Mandalorian. It opened doors to students, scientists, and creators alike. It didn't just power scripts, it powered dreams. As long as there are problems to solve and ideas to build, Python will be there, adapting, inspiring, and writing the next chapter of innovation, one line at a time. And somewhere on the red dust of Jezero Crater, Perseverance continues its mission. Powered in part by the quiet strength of Python code written millions of miles away,